previous video, there are few important terms that we should all know. The parameters of this respiratory parameters that will assess the given state of the lungs to make to understand whether they are normally functioning or not. So what are these parameters? There are certain parameters that are listed. So these parameters that I'm going to discuss are very important. There are other parameters discussed in the book, but these are very important parameters that as engineers we should know for better understanding of this ventilator system. Okay, so ventilator system will display these terms for the doctor to understand what is the current state of the patient's lungs. Okay, so what is lung compliance? Compliance elasticity, so something related to elasticity. Compliance of the patient lungs is the ratio of volume delivered to the pressure rise during the inspiratory phase in the lungs. This during the inspiratory phase, what is it? So a ratio of the volume delivered to the pressure rise during the inspiratory. So inspiratory phase, there is a volume to pressure ratio. This includes compliance of the airways. So if the volume, if the volume is more with the increase in the pressure, if the volume is more with the increase in the pressure, the compliance is more, bro. So that is the compliance is usually expressed in terms of centimeter liters per centimeter of H2O. Lung compliance is the ability of the alveolar lung to expand on the inspiration. That's very important. When there is a pressure rise or when there is an inflow, the volume should increase. If they don't increase, as I told you, there are several disorders on which these conditions occur. Okay, one of the biggest disorder, corona, what happens? It stiffens these muscles. So what happens is the lung compliance, the volume does not increase. So there is a very problem with lung compliance, and the lungs are passive, but they should stretch easily to ensure sufficient intake of the air. And ventilator, other parts of the breathing have compliance, and some sort of delivery volume is used to compress the expanded air. So when there is less lung compliance, they try to put the pressure into that, so that with the available volume, with the given rise in the pressure, the ventilator pumps in the air. Okay. So the compliance of patient's lungs is the ratio of pressure drop across the airway to the resulting flow rate through it. Okay, it is also expressed in flow rate. So flow, any fluid is liquid as well as gases. Fluid inside the flow rate, how much is the flow, that is controlled by the volume and pressure. Okay, so the lung compliance, so elastics of the different parts is directly proportional to all these terminologies. And if there is a problem, okay, with the lung muscles, this terminology can easily help us. And the flow rate as another flow, as current flow or any other flow, no, there is a blockage. Okay, there is an airway resistance comes into play, relates to the ease with which the air flows through the tubular respiratory structure. Here the resistance occurs in smaller tubes such as bronchioles and alveolar, which are emptied. Okay, so if there are they have the predefined resistance values. If it is more, then there is a problem. Mean airway pressure, an integral taken over the complete cycle of the mean airway pressure. This is mean airway pressure. So during the inspiration phase, if you say is this the mean airway pressure, and it's the inspiration phase and the expiration phase, and this entire cycle in integral taken over the entire cycle, if you see here, that is the mean airway pressure. Okay, and so when the pressure in the patient circuit and the alveoli is equal, there is the period of no flow. There is no pressure change, no pressure gradient, there is no flow. This period is called inspiratory pastime. Okay, and it can be seen at this here. Okay, so there is this flat line that can show you that. Okay, and inspiratory flow is represented with a positive flow above zero. Expiratory flow is the negative flow below zero. Okay, tidal volume is the depth of breathing. If you see the volume, the tidal volume is the breadth of breathing gas inspired or expired during the inspiration. It can be calculated by multiplying the flow rate setting by the inspiratory time. Calibrated tidal value ranges from 0.001 liter to 4.8 liters. If the flow is set to 0.6 liter per second, the inspiratory time is set at 1 second. Okay, the tidal volume is 0.6 liters. Okay, so this is how. So they have practically told us how do you even understand this. So tidal volume, also volume is liters, right? The volume is something in terms of liters. So if you set the flow rate at 0.6 liter per second, and per second it will fill a liter of 0.6. Okay, so 0.6 liters per second. If the inspiratory time is so inspiratory time is how much time you take to make one inspiration phase. The one inspiration phase, that is one breathe in, and the time, that is inspiration time. Okay, and expiration time, that is the how much time you take to complete one expiration cycle. Okay, So the unminute volume, this refers to the volume of gas exchanged per minute or minute volume during the quiet breathing, and minute volume is obtained by multiplying tidal volume by breathing rate. Okay, so tidal volume, you know, let's say 0.6 liters into breathing rate, what I told you, 15 to 15, so you get the minute volume. So per minute, what your volume is. So these are some important parameters that you should understand to basically know understand the patient's condition. There are also other parameters given in your book, but I and respiratory rate, no times, as I told you, number of breaths per second is another important stuff. But more importantly, these are the important parameters that we saw. Other things are more also important, but for the sake of this class, I am restricting till respiratory rate. Okay, thank you.